Hello, grade 10s. Shortly we'll be joining Omashni as she uses simultaneous equations to solve word problems. We will look at a problem that involves digits and also recap all the work we have done on simultaneous equations so far. Let's join her now.
Before we solve this problem, we need to understand what is meant by the digits in a number. Consider the number 345. How many digits are in this number? There are 3 digits, namely 3, 4, and 5. The digit 3 represents 3 hundredths, and we write 3 times 100. The digit 4 represents 4 times 10. And I guess you know that 5 represents 5 units. So the numerical value of the number can be written as 3 times 100 plus 4 times 10 plus 5 times 1. Keep this in mind for our next problem. The sum of the digits in a 2-digit number is 7. When the digits are reversed, the new number exceeds the original number by 27. Find the number. Let's start by making sure that you understand the question. Think of any 2-digit number. I'll choose 10, 23, and 43. Now, in our example, the sum of their digits must be 7. Do any of these numbers have digits that add up to 7? Yes, this one here, 4 plus 3 is equal to 7. So the sum of the digits is 7. But back to the question. We're looking for a 2-digit number. So this means that there are 2 digits that are unknown, even though there's only one whole number. Let's call the first digit T, because it represents the tens column. And we'll call the second digit of the number U, because this represents the units. This means that the number looks something like this. T, U. The sum of the digits is 7. Can we write this as an equation? Yes. T plus U is equal to 7. This is the first equation that we can use. Let's try to set up a second equation. What else do we know about this number TU? Be careful. In this case, TU does not mean T times U. It is representing one number with 2 digits. This rectangle represents the tens, and this oval represents the units. Now, what is the actual value of this number in terms of T and U? Remember that we said in 345 the number of tens was 4. So the digit 4 represents 40. So how many tens do we have in TU? We have T tens. So the value of the number is T times 10 plus U. We can write this as 10T plus U. What other information can we get from the question? The question says when the digits are reversed. What does this mean? It means that we swap them around. So instead of having TU, we have UT. Can you see that we just reverse the order in which the digits appear? But what is the value of UT? Let's understand what this UT means. Does it mean U times T? Nope, it does not. Be careful here. UT is actually the value of our tens column plus the value of our units. So it is equal to U times 10 plus T, which simplifies to 10U plus T. Let's continue reading so that we can see the relationship between the numbers. When the digits are reversed, the new number exceeds the original number by 27. Remember that exceeds simply means that it is more than. To show the idea of more than, we simply need to add 27 to the original number. So we can write 10U plus T, which is the new number we found, is equal to 10T plus U plus 27. This simplifies to 9u is equal to 9t plus 27. And we can call this equation 2. Again, we have two equations that we will solve simultaneously. I plan to use the substitution method. From equation 1, we can write u is equal to 7 minus t. So we'll use this to substitute into our second equation. Now I have that 9 multiplied by 7 minus t is equal to 9t plus 27. Next, I multiply out the brackets. I get 63 minus 9t is equal to 9t plus 27. To get the t's on this side and the constant numbers on this side, I can subtract 9t on both sides and subtract 63 on both sides. So negative 18t equals negative 36. So t must equal to 2. So the tens column of our number has a 2 in it. Remember, I still need to find the value of u. How do I do that? I substitute t equals to 2 into equation 1. So I get 2 plus u is equal to 7. And this simplifies to u equal to 5. So, in the units column of the number is a 5. Remember what the question asked for. We wanted to know what the actual number was, not just the digits. So I can write that t is 2 and u is 5. And the number is 25. Now we found the answer, but we need to check that it works. Do the digits add up to 7? 2 plus 5 is equal to 7. So yes, so far so good. If I reverse the original number, I get 52. Remember, the original question stated, when the digits are reversed, the new number exceeds the original number by 27. So we can subtract 52 by 25. And I get 27. So that's correct. Are you confident about solving this type of problem now? I hope so.
Thank you for joining us, grade 10s. Remember to look at the tasks for this section in the equations and inequalities task video. You'll also be able to learn more about equations on our website, www.mindset.co.za/learn. Goodbye.